Okay, folks, there's been a lot of videos this week, but this is the very last one. My shoulder is sore. I did all of these in one marathon session. So, I'm relieved. All right, last video. So now that we've learned the other trig functions, secant, cosecant, cotangent, now let's look at how we can use the trigonometric identities that we've established so far, basically just the reciprocal identities and the quotient identities. We're going to see how we can use those to simplify expressions. So let's look at an expression involving some trig functions. Secant of t divided by tangent of t. Okay. What you can do is you can take all the trig functions and rewrite them all in terms of sine and cosine. Every trig function, any one of the 6 trig functions can be written in terms of sine and or cosine. So that would be cosecant, secant, tangent, and cotangent can all be written using reciprocal or quotient identities. So secant is 1 over cosine, and tangent is sine over cosine. So that's what I mean when I say that they can be written in terms of sine and cosine. You can use those identities and replace them, like so. All right? So that is going to allow us to simplify this. So this is a compound fraction. Instead of writing divided by this fraction, I'm going to take my numerator, 1 over cosine of t, and write times the reciprocal of this fraction, cosine of t over sine of t. Like that. Okay? So dividing by a fraction is always the same as multiplying by its reciprocal, so that's nothing new. But then, now that I've written it that way, it's pretty clear to see that the cosine of t factor is going to cancel out by division, which leaves us with 1 over sine of t. And if I'd like, I can rewrite that in its reciprocal format as cosecant of t. So that has simplified secant divided by tangent to just cosecant. So there you go. That's an example of simplifying an expression. That's the only one I'll do for this video. My arm really is genuinely getting tired, so I'm going to wrap this up as quickly as I can. The last thing I want to put out here for you is some alternate forms of the Pythagorean identity. All right, so we learned the Pythagorean identity in a previous video. I'm going to write it again. It's cosine of t squared plus sine of t squared equals 1. That's always true. No matter what t value you put in there, it'll always be true. So if we take this entire equation and divide both sides by cosine squared, we can distribute that division over the addition. So each individual term is going to get divided by cosine squared. So cosine squared, cosine squared, cosine squared. And then this, we were dividing everything by cosine squared. This first term is equal to 1, because it's cosine squared over cosine squared, so that's just going to sort of cancel out and give me 1. And then the second term, sine over cosine is tangent, right? That's one of the, we were doing that right here, right? See, sine over cosine is tangent. So both of those are squared, so this is tangent squared. And then over here, 1 is the same as 1 squared, and 1 over cosine is secant, so that is secant squared. So what we've come up with here is this alternative version of the Pythagorean identity that instead of involving sine and cosine, it involves secant and tangent. And so this is something that we'll use occasionally. That'll be kind of useful. And then lastly, if you take the same thing and instead of dividing everything by cosine squared, if you divide everything by sine squared, we get a sort of similar result, but involving some different functions. Cosine over sine is cotangent, so this first term is cotangent squared. Sine squared over sine squared is 1. And then on the right side, 1 over sine is cosecant, so we get cosecant squared. So there we go. So that's our alternative versions that we will use occasionally when we need them.